In 1924, the world learned about the Andromeda Galaxy, challenging the belief that the Milky Way was the only massive spiral galaxy in the vast universe. This discovery thrilled astronomers and sparked the search for new galaxies, suggesting that we might not be alone. Over the decades, enormous telescopes like Hubble and James Webb have been created to look for extraterrestrial galaxies. Since the Webb telescope was launched, it has made headlines for observing thousands of colossal galaxies. Now, the James Webb Telescope has made new groundbreaking discoveries that could change everything we know and force us to revisit all our cosmological theories. Revolutionary findings that could completely alter our understanding of the universe. Continuing its series of discoveries challenging the Big Bang, the James Webb Telescope has found the most distant galaxy cluster ever seen, located 30 billion light-years away. Researchers say it could be one of the largest clusters in the universe. All 7 galaxies in the group had already been observed with the Hubble Space Telescope, but scientists did not know how far they were or if they were actually connected. Since light takes time to travel from distant objects to the JWST's position orbiting the Sun, the telescope sees these galaxies as they were about 650 million years after the Big Bang. As it currently appears, the protocluster looks small. But if its light could reach us instantly, showing us how it looks today, it is highly likely that it would be colossal, having gravitationally bound with thousands of other galaxies. Researchers' simulations suggest that this protocluster might now be one of the largest clusters in the universe. Recently, the James Webb Telescope also discovered a tiny galaxy from 13 billion years ago that has been forming new stars at an exceptionally high rate for its small size. It is said to be the smallest galaxy ever discovered at this distance. In a groundbreaking discovery, a team of researchers from the University of Minnesota used the James Webb Telescope to peer over 13 billion years into the past and uncover an extraordinary tiny galaxy that has been forming stars at an extreme rate for its size. This tiny galaxy is one of the smallest ever discovered at this distance, around 500 million years after the Big Bang. If that doesn't excite you enough, you should know that this tiny galaxy could potentially help astronomers better understand galaxies that existed millions of years ago right after the universe's explosion. This galaxy is far beyond the reach of all telescopes except James Webb, and these unique observations of the distant galaxy are spectacular, said Patrick Kelly, senior author of the study. The galaxy is about 1/1,000,000th of the volume of the Milky Way, but interestingly, it still forms the same number of stars each year. It's incredible. If you're wondering how the James Webb Telescope can observe such small details in a field wide enough to capture the entire galaxy cluster at once, it's primarily due to a phenomenon called gravitational lensing. Gravitational lensing uses lenses to bend and magnify light coming from the mass present in the galaxy or galaxy cluster. Thanks to gravitational lenses, this tiny galaxy appeared 20 times brighter than it would have without them. This is apparently the first case where it has been possible to examine most of the path back to the Big Bang. The James Webb Telescope, with its galactic exploration capabilities, has made all this possible. In July 2022, astronomers discovered Glass Z13, which seemed to be the oldest galaxy in the observable universe. But a new contender has come into play, and it is so far away that it might challenge our models of the universe. In a preprint paper published in August 2022, Rohan Naidu, an astrophysicist at Harvard University and the Center for Astrophysics, jointly managed by Smithsonian, detailed another distant galaxy candidate from one of the JWST's early release science programs, known as CIRS 1749. It is an extremely bright galaxy that, if confirmed, would have existed just 220 million years after the Big Bang, and could even rewrite our understanding of the cosmos. But there's an important complication. CIRS 1749 might be one of the farthest galaxies we have ever seen, or it might be much closer to home. The data seem to indicate 2 possible positions for the galaxy, and we won't know which one is correct without further observations. For this reason, it has been nicknamed the Schrödinger Galaxy. How can a galaxy seem to be in two different places? It's all a matter of redshift. To determine a galaxy's distance, astronomers study the wavelengths of light. In particular, they are interested in a light phenomenon known as redshift. In simple terms, light waves leaving distant galaxies stretch over time, shifting the waves along the electromagnetic spectrum and making them more, well, red. So, the ultraviolet light leaving a galaxy like Schrödinger won't reach Earth as ultraviolet light. Instead, it will be shifted to red in the infrared, which is advantageous for us because that's exactly the type of light Webb looks for. And Webb has various filters that observe different wavelengths of infrared. When examining a galaxy like Schrödinger, wavelengths can be analyzed as if flipping through a photo album. On the early pages, with less red wavelengths, nothing is visible. Then, flipping and observing more red wavelengths, the ghost of a galaxy appears. At the most red-shifted wavelengths, on the back of the album, the galaxy is a clearly defined object. This would also mean that we might need to revisit our models of how galaxies evolved in the early days of the universe. Galaxies from so long ago shouldn't be so bright, at least according to the current model. But perhaps we don't have to break the laws of physics. It could be that Schrödinger is actually a satellite galaxy of one of its more massive neighbors, and thus much closer to us. Another group of researchers studied the same galaxy from early release data on the same day. Org Zavala, an astrophysicist from Alma, Japan, and his team combined JWST data with that from a ground-based telescope in the French and Hawaiian Alps. They concluded that Schrödinger might be an imposter, masquerading as a high redshift galaxy when it could actually be a much closer dusty galaxy in a rapid star-forming phase. Scientists are in a quandary, as the data suggest two potential locations for Schrödinger, and no one is yet sure which one is correct because further investigations and observations are needed. In particular, spectroscopy will allow astrophysicists to examine its redshift more accurately. The only barrier now is time, having enough time on telescopes around the world to study Schrödinger and solve the puzzle. But wait, Schrödinger was just a part of the vast image released by Webb. The images indicate that massive galaxies were already forming in the early days of the reionization epoch, when the plasma that evenly filled the primordial universe collapsed into stars and more familiar galaxies. Despite its enormous size and all the ancient galaxies contained within it, the image represented only a tiny sliver of the sky. The atmospheres of exoplanets, located in the habitable zone of their stars, artificial lights around exoplanets, and the study of Jupiter's and Saturn's moons are just some of the numerous investigations the super telescope will conduct. Speaking of exoplanets, Webb captured the very first image of an exoplanet. Astronomers revealed the first photograph of an exoplanet taken by the James Webb Space Telescope, JWST, from NASA. The image showed the bright spot of a world 7 times heavier than Jupiter, orbiting around a star about 400 light-years away. The groundbreaking result was the latest in a series of firsts for the telescope's exoplanet discoveries and a test of technologies that will allow direct imaging of Earth-like planets by future space telescopes. It is nothing short of exhilarating. To photograph the hot and young giant IP65426b, JWST blocked out the light of its host star using a small mask known as a coronagraph. This revealed the orbiting planet, which was thousands of times fainter, like a firefly around a spotlight. IP65426b orbits about 100 times farther from its star than the Earth is from the Sun, taking 630 years to complete an orbit. This distance made it easier to see the planet against the star's glare. Additionally, the planet's extreme heat and brightness, with a temperature of about 900 degrees Celsius, a remnant from its formation just 14 million years ago, made it a prime target for direct imaging. Surface features of IP65426b were not visible in the image, but it is expected that it might appear banded like Jupiter, with belts caused by temperature and compositional variations, and it might have spots in its atmosphere caused by storms or vortices. The giant planet is inhospitable to life as we know it, but it represents a class of large planets scientists are eager to learn more about. Each week, we eagerly await Webb to show us our cosmos as never seen before. And surely, with further discoveries, new challenges to existing models of the universe will arise. After all, what is science if not questioning and rethinking everything we know? Thank you for watching. If you enjoyed the video, please like and subscribe to the channel.